Okay, today we're going to do some mixed practice factoring. Okay, remember you have three main types of factoring that we're working on. First, and always first, greatest common factor. Then we have the difference of two perfect squares or conjugate pair factoring, and that really only works when we have subtraction between two things that are both perfect squares. And then we had trinomial factoring, okay, for quadratic trinomials. All right, so we're going to kind of take a look at all of that in one little clip here. All right, so first up, I've got 8x squared plus 16x. I want to factor. Very first thing I'm always going to think is, do I have a greatest common factor? Take a look. As it turns out, I do. 8 and 16 have a common factor in 8. X squared and x, they have one x to give me. He has 2, but since this one only has one x, that's the only thing that I'm able to take from both of them. Okay, and now, really, what goes in the parentheses is just what's left when I divide out an 8x. 8 over 8 divides itself out, that's just 1. X squared over x, there's 2 x's up here, 1 down here. One of them divides out, and I'm left with x. That's exponent rules, right? 2 minus 1, x to the first. Plus in the middle, 16 over 8 leaves me with 2, and x over x divides itself out. So I just have x plus 2 in there. I can check this. Either I'm multiplying this out and making sure I get the original, or I'm graphing the original, I'm graphing my answer, and I'm making sure that they overlap. And do remember, when you're home, you don't have a graphing calculator, Desmos.com is your place to go. All right, let's take a look at another one. 24x squared minus 54. Doesn't matter what format it's in, the first thing I'm always going to ask is there a greatest common factor? 6. Take a 6 out of both of those. So again, I'm going to divide out a 6. And what's left? 24 over 6 is 4. X squared is untouched. Minus in the middle, 54 over 6 is 9. I'm going to always look, we didn't really do it over here and we probably should have, but I'm always going to look at what's left in the parentheses and make sure that it's not factorable. So coming back over here, x plus 2, I can't factor that. There is no greatest common factor. It's not the difference of anything because it's addition, and it's not a trinomial. Here, 4x squared minus 9, that is the difference of two perfect squares. 4 is 2 squared, x squared is x squared, 9 is 3 squared. They're all perfect squares, so they're going to factor into those conjugate pairs we saw in class. 4x squared comes from 2x and 2x. 9 comes from 3 and 3. 1 is plus and 1 is minus. Okay, these could be in either order. So this could be 6 times 2x minus 3 times 2x plus 3. The order here isn't really that important. And again, this is checkable. I could either multiply all this out or graph both of these. One last check. This is not factorable. If I cover everything else up and just look at 2x plus 3, there is no greatest common factor. It's not the difference of anything, and it's not a trinomial. Same thing here, no greatest common factor. And while it is a difference of two things, neither of them are perfect squares, and it's not a trinomial. So this is completely factored. Let's look at one more. Okay, we've got 2x squared plus 8x plus 6. What am I looking to do first? Should be finding that greatest common factor if there is one. Now remember, there's not always one. This one happens to have one, though. It's 2. When I factor it out, I'm left with x squared plus 4x plus 3. Okay, and again, I'm looking at the inside of the parentheses now. Is this factorable? It is. It's a quadratic trinomial. So we did some of these in class. We know that quadratic trinomials factor into two binomials, usually. Okay, x squared comes from x times x. And then we're looking for factors of 3, which is kind of a small list. 1 times 3 is 3, or I could have done -1 times -3. I need to add them up to get positive 4x, so it looks like it has to be +1 plus 3. Okay, we also did learn yesterday the box method. And I just want to point out that this works on all quadratic trinomials. So first term in the first box, last term in the last box, multiply them. 3x squared. And list factors. So again, 1 and 3, -1 and -3, those are still the only factors of 3. X squared comes from x times x. It's still going to have to be 1 and 3 though, because they still have to add up to 4. So I get 1x and I get 3x. Once your box is filled out, you're factoring greatest common factors down each column and across each row. So x squared and 3x, they can both give me an x. 1x and 3, they can both give me a 1. So x plus 1 is my first factor, which we already knew. Across each row, x squared and 1x, they can give me an x. 3x and 3, they can give me a 3. So x plus 3, which again, we already knew. We don't have to worry about negatives here because none of my insides were negative. Okay, remember, if it's on a negative box, the term will be negative. And again, this is checkable. Either graph and graph or multiply it out.